Hello everyone, this is I Believe Great Time Math, and today we're going to be finding the midpoint and the distance of the line. So this concept in general is not really difficult to understand, so I'll zoom into this really quickly. So midpoint and distance of the line. So midpoint, there are two methods to this. The first method is to plot your points, inspect, and average. The second being plotting the points and then using the aforementioned formula. So this may seem very difficult to understand at first. What is plotting a point, inspecting an average? So we'll quickly jump into that. Um, so find midpoint. Okay, we have this line, and the top one is labeled x, bottom one is labeled y. Immediately, you'll see that the line fits really well into this graph, into this Cartesian plane. And when you see this, you can almost instantly just interpret the midpoint. And this is labeled z, so m would just by looking would equal -3, -3. So, look, we just used the first method, plotting points here, inspect, and then average, which is essentially interpreting the middle of the point. Now, now it may seem really easy to find the midpoint in all lines, but this is actually a really limited example. I would probably never use method one for really anything, unless it's a really simple one-mark question. So this hardly ever comes up. If so, it will be a really, really easy question. So in this case, this question, you don't need to use the formula. Now let's hop on to another case where you would need to use the formula. So LM, let me plot the point, LM. This is a really poorly drawn line. Ideally, if the teacher gives you a question like this, use your ruler. Now you have X and you have Y. Let's just state what X is first off. It's -3, 3, and Y would be 3, -1. So this would be our 2 points. X is equal to -3, 3. Y is equal to 3, -1. Now, as you can see here, we use the formula here. And if you really look at this, you can't really interpret the middle properly. So you must use this formula. And now you run into another problem. What exactly is x1, x2, y1, y2? Well, if you recall, every coordinate has an x and a y value. The first coordinate and the second coordinate, we have two pairs, x and y in this case. So the first pair would be x1 and y1. So naturally, you realize the second pair must be x2 and y2. And boom, you have your midpoint formula. Now, you should understand that it doesn't matter which pair is x1 and which pair is x2. I could flip them. I get the exact same answer. And the reason for this is that in this case, you're adding it together, and it doesn't really matter which one's x2 and x1. So let me just plug it into the formula real quick. Um, in this case, x1 plus x2 over 2 and plus y2 over 2. Now, I hope you realize that in this case, you must always, for this formula, include the brackets. Now, this is a really easy way to lose marks because you must understand that when solving for midpoint, you're solving it within the frames or the brackets of a coordinate. So at this point, this is actually a variable coordinate, but we still need to simplify it. And so we get to here, 0, and just do that real quick in your head. That would be 1. And in this really poorly drawn line, you'll see that if I drew it better, the midpoint would in fact be 0, 1. And I misspoke. It is actually pretty easy to find the midpoint, but I find it to be a pretty good demonstration of how to use the aforementioned formula. Now, hopping really quickly to the distance between 2 points, I'm going to understand the formula, as you can see here. You must understand what the Pythagorean theorem is. So in grade 8, you probably understood and learned how to find the hypotenuse with two sides. And the teacher probably gave you this formula, c squared plus a squared equals b squared. Now, you probably know what that c squared is equal to the hypotenuse, a squared one side and b squared the opposite side. Now, as you can see here, we have one line. And how does this theorem really relate to what we're trying to do at hand? Well, If you take a look at this line, this is a really long and slanted line, and this makes a perfect hypotenuse. So this will be our C value. And we draw a component of that line, two components. And this would be A and B. And now it's looking strikingly similar to that of a right angled triangle. Now, whatever happens here is actually this. Whatever happens in this formula is essentially this. Now, let me just copy that formula real quick. Equals x2 minus x1 squared plus y2 minus y1. So, you may immediately notice some resemblances. And in order to facilitate that, I'm going to simplify the Pythagorean theorem into this. Now you can see that d, the distance, is essentially the hypotenuse. We established that here. And so what is this point, and why is it equal to A, and what is this point, and why is it equal to B? Well, I have an explanation for that, and this may seem really confusing at first, but in reality, all you really need to know is the formula. But it's nice to see how it's derived. We have B and we have A. So let's just say B, X, Y. These are 2 points. And because this is the first one, we're going to say that this is X1 and Y1. And because this is second, it will be X2 and Y2. These are the points. I'm not going to find out exactly what they are, but it works pretty well because it is exactly included in the distance formula, right? So as you can see here, in terms of X1, from X to the point, it is exactly 1 unit. And now from X2 to this point, it would be exactly 5 units. Now, 1 unit minus 5, 1 minus 5 would be 4 units, which is exactly the length of this A component. So X2 minus X1 directly substitutes into A. Now you could do this with the Y value too. Let's start from here. This is 5, right? And this is 1. So then if we subtract this, sorry, this is 4 and this is 1. If we subtract this, it would be directly equal to the B value. And see, you can easily see how this essentially makes up the Pythagorean theorem. Now, in here, we're going to do some application. And we have this formula, and we have the points. Usually, they won't be plotted. And you should be using ruler to draw the line. But in this case, they are. Let's just say this is x1, and this is y1. And let's just say this is x2 and this is y2. So now you may be wondering, does it really matter which one is x1 and which one is y2, y1? Well, in this case, no. I will not be showing you why, but I think you can infer why. If you look at this square, if you switch the 2 points, it would give you either the same number or the number that is negative but equal to the same number, absolute value. Now, what exactly does the square do? It gets rid of the negative and essentially makes it positive. So any number, regardless of whether it is added or subtracted, will always result in the same solution because it is squared. So in this case, it doesn't really matter. So let's just follow the formula. 12 minus 7 squared plus 0 minus 12 squared. Now, I can actually demonstrate right now. Let's say this was flipped. Let's say it was 12 minus 0 squared. 0 minus 12 squared is the same negative 12 squared. It's the same as 12 squared because, it's just how squares work. And so we just simplify this. This would be 5 squared, and this would be negative 12 squared. Just pull up the calculator. 5 squared would be 25 plus 144. And the result would be, let's see, would be 13 units. Now, in these questions, when there's no unit mentioned, you just write unit. And this would also apply in the therefore statement. You would say that the distance between A and B would be approximately, no, actually, exactly 13 units long. And that's how you find the distance between 2 points. Pretty simple.